Dear students, today we are going to look at this JAMB chemistry question. This question is from electrolysis, that is electricity chemistry. And the question number 1 states, a quantity of electricity liberates 3.6 grams of silver from its source. What mass of aluminium will be liberated from its source by the same quantity of electricity? Okay, a quantity of electricity which is unknown liberates 3.6 grams of silver. Okay, and the question is asking us to calculate the mass of aluminium that will be liberated by the same quantity of electricity which liberated 3.6 grams of silver. So what are we going to do? We are going to solve for the quantity of electricity that will liberate 3.6 grams of silver from its source. Now, we will now use that quantity of electricity we solved, which liberated 3.6 grams of silver from its source, to solve for the mass of aluminium that will be liberated by the same quantity of electricity. Okay, now let's solve it here. The Faraday's law is mass is proportional to what? Quantity of charge. Mass, when you remove this sign, you have Kq. The K represents the charge of metals, okay? The charge of the element or substance. Then the mass of, we are solving for quantity of electricity that will liberate 3.6 grams of silver, okay? Now, the mass of silver here is 108. It's constant. That is the relative atomic mass of silver, 108 gram, against the charge for silver is 1 multiply 96500. Okay, this is 1 farad. Then we have here 108 gram against 96500 coulombs. 1 multiply this will give you this. Okay, then what quantity of electricity will now liberate 3.6 grams of silver? Here we are going to cross and multiply. This multiply this will give us 108x against 96500 multiply 3.6. That will give us 347,400 divided by 108 divided by 108. This we cancel this, s becomes equal to divided by 108. This will give us 3216. That's 3206.67 coulombs. This is the quantity of electricity in coulombs that will liberate 3.6 grams of silver. Now, we are going to use this quantity of electricity to look for how many mass of aluminium that it will liberate. That is what the question is asking us. Okay, what mass of aluminium will be liberated by the same quantity of electricity that liberated 3.6 grams of silver? And from what we've solved so far, 3,216.67 coulombs of electricity liberated 3.6 grams of silver. Okay, so we are now going to look for the mass of aluminium that will be liberated by the same quantity of electricity. Now, the relative atomic mass of aluminium is 20, that is 27. It's not in the question, it's constant. 27. Then aluminium liberates how many farad? 3 farad. That is 3 times 96500 coulombs. Okay, you bring it down here. 27 is against what? 3 Faraday. 3 Faraday will be 3 times 96500. That is 289,500 coulombs. This is gram. Okay, then what mass will be liberated by 3216.67 3216.67 columns. Okay, then we cross and multiply. We are going to have here 289,500x against 27 multiply 3216.67. That is equal to 8685.09 divided by 289,500 divided by 289,500. This will cancel this. S will give us divide by 289,500. That will give us 0.30, okay, gram of aluminium. Okay, the same quantity of electricity that liberated 3.6 gram of silver will liberate 0.3 gram. So the answer here is D. Option D is the answer. Okay, we first solve for the quantity of electricity that will liberate 3.6 gram of silver. Then after that, we now use that quantity of electricity to solve for the the mass of aluminum that it will liberate. Okay, the next we're going to look for now, that is question number 2. Question number 2 says, if the cost of electricity required to deposit 1 gram of magnesium, if the cost of electricity required to deposit 1 gram of magnesium is 5 naira, how much would it cost to deposit 10 gram of aluminium? The relative molecular mass of aluminium is 27 and that of magnesium is 24. Okay? If the cost of electricity required to deposit 1 gram of magnesium is 5 naira, how much would it cost to deposit 10 gram of aluminium? Now let's move to the solution. Now, the cost of electricity to deposit 1 gram of magnesium, 1 gram of magnesium costs how many naira now? 5 naira. Okay, how much would it cost to deposit 10 gram of aluminium? Okay, then here, to solve this, how much would it cost to deposit 10 gram of aluminium? We are going to solve for the quantity of electricity that deposits 1 gram of magnesium. Okay, the quantity of electricity that deposits 1 gram of magnesium, which will cost 5 naira. Now, how much will it cost to deposit 10 gram of aluminium? Okay, so let's solve for the quantity of electricity that will deposit 1 gram of magnesium. Okay, then here, magnesium here is 24. Magnesium is 24. That is 24 gram. Against the charge is 2 Faraday. That is 2 times 96500. 193,000. Okay, then 1 gram will deposit what? X. You cross and multiply. This will give us 24x against 193,000. Okay, divide by 24, divide by 24. This will cancel this. X is equal to, divide by 24, will give us 8041.67. This is the quantity of electricity that will liberate 1 gram of magnesium. Okay, that is 8041.67 7 coulombs. Okay, then we are going to solve for the quantity of electricity that will deposit 10 grams of aluminium. Okay, aluminium here is 27 against 3 farad. That is 3 times 96500. 3 times 96500. That gives us 289,500. Then 10 gram will cost us how many? Okay, if you cross and multiply, 27x is equal to 289,500 divided by 27 divided by 27. X is equal to 289,500 divided by 27. That gives us 107,222.22 coulombs. Okay, so here the quantity of electricity that will liberate 1 gram of magnesium is this, and this is the quantity of electricity that will liberate 10 gram of aluminium. Okay, in that case now, this guy here, this quantity will cost 5 naira. How much will cost this quantity? That's what the question is asking us. Okay, if the cost of electricity required to deposit 1 gram of magnesium, okay, 1 gram of magnesium requires what? 5 naira. That is the cost for it, for 1 gram of magnesium, 5 naira for that quantity of electricity. So here we just solve for that quantity of electricity that will cost 5 naira. Okay, then here we now solve for the quantity of electricity that will liberate 10 gram of aluminium. Then we now use that now to relate to this to get the cost it will cost for 10 gram of aluminium. Is that okay? So here we have 8041.67 against 5 naira. I think I have to wipe here. I have to wipe this off. This is what we have for 10 gram of aluminium. Now here, 8041.67 because 5 naira. Okay, then 107,222.22 because how many naira? This multiply this will give us 8041.67x against 5 multiply 107,222.22. That gave us 536,111 divided by 8041.67 divided by 8041.67. This will give us x is equal to divided by 8041.67. That will give us 66.67 naira. Okay, 66.67 naira. Do you have it here in the option? Okay, this is the answer. Okay, we solve for the quantity of electricity that will liberate this, and that quantity of electricity that will liberate this costs 5 naira. Okay, now how many quantity of magnesium now? Okay, we are now asked to calculate the cost it will cost for 10 gram. Okay, so if that quantity of electricity that will cost 5 naira is this, as we solve it now. Okay, and this is actually the quantity of electricity that will liberate 10 gram. In this case now, we are no more relating this with 10 gram again. We are solving this with the quantity of charge. That quantity of charge for magnesium is this, and that costs 5 naira. And this is the quantity of electricity that will liberate 10 gram of aluminium. We now use that, relate the two together, solve for x, and the answer is 6.67. This is the answer. Okay, please don't forget to subscribe to our channel. Okay, more chemistry questions are coming up in this channel. Thank you, and God bless you.